Okay, so we'll be starting today with the next part from subsets. Okay. Now we'll be trying to take some questions and then we'll discuss some problems related to it and then we'll move further accordingly. So question number 1, suppose. Write down all subsets of set where 1 and 2 elements are there. So we have to write down the subset of this set A containing 2 elements 1 and 2. Now listen very carefully. Subsets means subcollection. So directly you can write subsets of A 1, 2 are. Null set is always considered as a good collection, right? It is a collection of subcollection of the given set. Always it is a subset. Then we consider the sets containing one element. That means taking one element at a time from the given set. Taking one element at a time from this given set, we are considering this and this. So when we finish with one element set, then we have to move on to two elements. Now if I write two elements, there will be only this set because the whole set only contains two elements. So this is the answer of the first question. Now suppose that same question I would like to arise. Here I write 1, right? So now next set I want to write, say set B, where I have three elements ABC, and I would like to write the subset for this particular set. I want to write the subsets for this particular set. So anyway, I am writing a statement, subsets are. First of all, always we have to take the null set Y. Then you take one element set. This is A. Then set containing one element B. Then one element C. Fine. Once one element is finished, you have to take two elements. So we have done. And once you have finished with two elements, then we have to take three elements. So now once we finish with three elements, here in this case, I have to stop because the whole set itself contains three elements. So I cannot get a collection, subcollection containing more than three elements. So this is over. Now similarly, if I have a set, let me go little ahead. Say set C is there where I have four sets. Now here also I have to write. Here also I have to write the subsets. So subsets are what? 5. This time I have to write 4 such sets where single elements will be part. Then I have got such few sets containing two elements. How many will be counting it? CD, right? Then I'll write here DA. Then I can have A comma C. I can have B comma D. Now these are the all possible combinations of two elements. So I cannot get more than this. So once we finish it, then we have to go for collecting three together. So it may be ABC, it may be B comma C comma D. If you write it in serial order, then you will not miss the elements. Then CDA, and one more will be there, that is DAC. And once you finish with all three, then you have to write the last. So this is the idea by which we can write the subsets. So this is the first part we did, right? So we have got this. Now you see this question, of course, nobody will ask you to write, say, one set. This is not for doing, just for example, I am doing. If somebody asks you, okay, there is a set D where there are elements 1, 2, 3, 4, and up to 9, 9 elements are there, and you write all the subsets. That will be a very bad question, because if somebody asks you to write this, it's very clear that you will not be able to do it. Because you will not be able to do means, what I want to mean is that it's a big question, such a big question which will take a lot of unnecessary time. So we should not try that question, and nobody should ask you that question. If someone is asking, that means it is not a good idea to ask that. So we will not ask you questions which are having more number of such elements. So we can maximum ask up to 6. Now, sorry, 4, not 6. This is the thing, not more than that. Now, one part of this only I would like to consider, say question number 5. What will happen if I consider the set where only one element is there? So here also I can be able to find a sub-collection. So the first sub-collection is 5, and second sub-collection is containing one element at a time. So these two only. Now, in the same idea, if I go back and I ask you that there is a set in which no element is there, then here I want to write the sub-collection. So here only one sub-collection will be there, 5, because once you try to write sub-collection containing one element at a time, it is not at all possible, because this doesn't have an element. So this itself is the required subset. So this is the notice observation you have to make, that if I consider an empty set, it has got only itself as its subsets, right? So that is a very important part to be noticed. Now, with this particular reference only, I am going to add one more thing to it before I go for the operations. Now I'll be going for the operations, but before I do the operation, let me write a definition here. The definition is important. So definition is that it is about a power set. Definition is about power set. We would have got this definition afterwards, but as we are doing this context, I am writing the power sets definition here itself. So what is a power set, right? The sorry, the set of all subsets of a given set is called the power set of the given set. The set of all subsets of a given set is called the power set of the given set. So that is very important. If A is the given set, if A is the given set, PA or 2 to the power A represents power set of 2 to the power A represents power set of A. Please note down that. Please note down that. And once you finish noting down, you will tell me. You will raise the hand. So, So now here I'd like to just say something. Just you try to see where I am highlighting. In this question, I am asking you to write down the subsets of this set, subsets. So we have written like this. So here only difference is that when I write the subsets, I did not write them in the form of a sets. Therefore, individually we have written. So now once I create one set by taking these as elements, these four as elements, then that set will be power set of this. So here, as already we have discussed the power set. Now I'd like to write just below here power set of set A. So in case of this, power set of A will be nothing but those sets only you have to write, right? Only difference what we did is that earlier we have written the elements. Earlier we have written the elements. Sorry, background has gone. So now I don't know how to make it undo. Ah, it is there. So let me cut it only. This will be 1 comma 2. So what is the difference basic we have observed here? Here we did not write this as the element of a set. We have simply written individual subsets. But here we have written those subsets in a pair of second bracket. Right? So these are the two advantages. So when we write them in the form of a set, then we get the power set. Otherwise, they will be treated normally as subsets. So actually knowing the subsets means you are knowing the power set. That is the idea. So similarly, if somebody asks you writing this power set of this, simply these elements only will be written in a pair of second bracket. Similar case will be applied for this. Similar case will be applied for this. Similar case will be applied for this. So now just example. Say if I write if A equal to 5, write this. What is this? A equal to 5. So that's a very important question because there is a good chance that students commit a mistake. First of all, in the side, I'm writing our subsets of this. What will be the subset of this? This is one and this is the another one. Many students commit a mistake thinking that this is very much same as 5 and they write only the 5. But this is not 5. This is a singleton set 5 where 5 is the element. So I have got 5 that is null set as its subset and the whole set as its subset. So when I ask about writing power set for this, so power set will contain here these two sets. Be very alert about this because these are the questions which creates problem for us. And suppose I write just create a confusion. I write like this and then for this I am asking you to write power set. Yes, here it will be simply this, right? Simply this means this one because it is a null set. This is a null set. So null set has only one subset that is 5. So that is to be written in a pair of bracket in order to say that it is the power set. So please note it down and once you finish it, tell me. I'll switch on to the next one. Okay. Now I'm going to the next board. In the next board, we are going to discuss about the operations. But before we discuss the operations, we would like to tell you that we have something called Venn diagram. Venn diagram. It's a very important part. Venn diagram. So actually, it is a diagrammatical representation. This has been found by the mathematician John Venn in order to represent the set. And this is the easiest form of explaining set for two common people. And we have been using it in many exams also. So I'm writing first. It's not a definition, just a statement that the representation of sets and its operations, sets and its operations with the help of geometrical figure like square, rectangles, circles, ellipse, triangles, etc. is called the Venn diagram. Is called a Venn diagram. So we call this a Venn diagram. Now, just suppose I would like to represent, I'd like to represent a set A in a Venn diagram. Simply, I'll write a structure like this. Structure like this, nothing else. I need not work very hard for this. Just a structure like this. Suppose we want to represent this set 1, 2, 3, 4. These are the elements in this form. So this will name as A, and we'll just write the elements here in a scattered way, wherever you want. So this is the way how we can write the set. So a circle may be there, an ellipse may be there, like this. So this is the way by which we can represent the sets A. So if I have another set, say 1, -1, 2, no problem. You use another figure. This is here, right? So, and you write the elements. You write the elements here. Anywhere you write, there is no such restriction that you should write 1 here, 2 here, etc. So this is the sets. So this is set A. This is set B. You must write here also. So this is how we represent the things. Please, once you finish, again you tell. Okay, thank you. I'll move to the next board. In the next board, we are going to discuss about very, very important part, that is the operations. Operations on sets. Operations on sets. Operations on set. This is a very important point. First operation is union. Union of sets. So to define the operations, we do it at the beginning for only 2 sets, then we can extend it for finitely many sets. Union of sets. Just to remember this, I am going to give you a keyword, that is mixture. mixture, right? You have to mix the two sets whose union is needed, right? I'll not write a very proper definition, not needed only. You go through the book. I'll write the symbolic definition. Say, first I'll take the example, then I'll show it with the help of general explanation, then I'll draw a figure. That is the Venn diagram. Say, I have two sets, 1, 2, 3, and another set is 2, 3, 4. Purposely, I have taken some common element. So now if I want to mix them, that is called the union, and this is the symbol I should use. This is the symbol I should use. This particular structure like U, it is looking like capital U, but write simply like this only. So this is the symbol for telling you that you are taking the union, and union means you have to write all these elements, but without repetition. So 1, 2, 3 we have written. So from here 2, 3 already collected. So here we will write. So this is the union. So union बहुत easy concept है. What you have to do? You have to write all the elements of the two given sets, and you have to construct a new set. That new set is known as the union. This is the union, right? So that's what you can easily do. Now, one thing you should observe. One thing you should observe. Suppose that somebody tells you you have to pick randomly one element from randomly without saying, and then one element you took from here. Suppose you have got from here one random element x. It may be 1, it may be 2, it may be 3, it may be 4, but you don't know which it is because randomly you have picked up from here. Now, will you be able to comment like this that x is belonging to A? Very definitely no, because it may be 4 also. If it will be 4, you cannot say that x belongs to A. You cannot even say that x belongs to B, right? But there is a very good comment, or there is a good chance to say that x must be in A or B. This is very sure. That means something which is picked up from the union is very sure to be there in either of the original sets or maybe in both of them, right? So why have I explained you this? I have explained you this because next whatever I'm going to write is the definition, which is symbolic one, which we basically need. That is A union B. If I want to write in symbol, I should write x such that what kind of x I have picked up, it should be from A or it should be from B. Maybe they are present in both. That is not an issue. But I am pretty sure that it is either in A or it is in B. Now, instead of writing this symbol or, in maths we have some symbol for that or also. So you may encounter that symbol. So I tell you that symbol or is represented by this simple V-like structure. No cutting. Cutting, if you do, that will be for all. So maybe or you write like this, or this is the symbol you will use. Please note it. Please note it. And once you finish, please, as you know already. Okay. Anyway, I missed actually one more thing to be discussed, that is called universal set. Right. So let me first talk about the universal set. Just a simple definition. I'll write the definition in the previous board. So you will also note down. Then we'll proceed for this particular concept. A very important I have missed actually. It is universal set. Universal set. Universal set. So you will be writing in any discussion. In any discussion related to sets and its operations, we always consider a bigger set such that remaining all sets under the discussion are subsets of it. It is called universal set, and it is denoted by U, capital U. Remember it, union symbol is also U, but there is a difference between this U and that U. In union, you should not write these two, right? So it is capital U, bold. So now I'll be giving a small example, then you will be able to make it sure how we understand this. Please note it down, and once you finish again, you indicate me, then I'll be able to write. Okay, I'll take the example here. Say in my discussion, I'd like to consider these two sets: 1, 3, 5, 7, dot, dot, dot. And another discussion is that 2, 4, 6, 7, dot, 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 6, 8. So here, if somebody tells you that your discussion is on these two sets, so you now tell me one set which can be acting as universal set for them. So that set I need, which will include both of them. So very clearly you can say that natural number can be considered as universal set for this discussion. Now, of course, natural number is the smallest option I am giving you. If you say that, sir, I want to consider integer, most welcome. If you want to say that I want to consider whole number, most welcome. Sir, I want to consider real number. Sir, I want to consider complex number. Anyone, right? But this is the smallest option which we have, which will include both these two sets as its subsets, right? So always under the discussion, when you do, you should be able to have a bigger set which will include both, or maybe 3, 4, 10 sets in the discussion, all should be included. That's all. So please observe this and note it down. You might have already noted, this will not take time to note. I'm going for the next board. So now we are going to represent this with the help of Venn diagram. Which union? You can see here. I have drawn one box. सबसे पहले at the very beginning it is your responsibility to set the boundary. This is the universal set. Now no matter what I'll discuss, no matter what I'll discuss, my every discussion will be here. I should not go beyond this. So this is my working area. So this is the idea of universal set. Now suppose that two sets I want to consider. Two different sets I want to consider. So if I want to consider two different sets, I'll write one set here. Suppose this is one of the set, say A. And then I'll be writing another set here. This is the set B, right? But there may be, there may be, there may be options. There may be options where they have something in common. They have something in common. If they will be having something common, my explanation should be like this. Like this means there must be some overlapping. There must be some overlapping because you see the examples, there are some common elements. So always whenever you make union, you take union, make sure that there is places for common elements. So this can be marked as A, this can be marked as B. Now, if I consider only these cases and I would like to represent it by Venn diagram, what I'll write first, I'll fill up the common elements and then the rest of the elements here. So now my Venn diagram is complete. So this Venn diagram represents A union B. Venn diagram, this means which particular part? The shaded area, right? Had I did it with the help of hand, I could have given shading, and that same shading I would have drawn here. But this time these are different shadings, right? Okay. So please try to understand. Okay. Now I'll be going for the next board for explaining the next operation. That is, next operation is intersection of sets. Intersection of sets. Intersections of sets. Now, intersection means keyword. Again, I would like to tell you, I'm going to give you something which always will be remembered. Intersection is keyword. Keyword is common. Intersection means common. So, explaining this, I want to take the same example so that it will be more comprehensive and appealing. So here if I ask you, intersection symbol is this, simply ulta of this previous one, and here necessarily you have to write only the common elements. Whoever are common elements, that only you have to write, nothing other than this. Union is the mixture, write all. Intersection is the common, write only the common. Only the common. Now try to be very sure. This time if I ask you to pick one element randomly from 2 and 3 or from intersection, this time you have a very good scope to say that you will be very sure from here if I pick any x, you will be very sure that x must be in both A and B because you have taken them from the common part. Earlier difference and this difference, please make a distinction between that. Earlier it was either A or B, but this time we are very sure, pretty sure that we have this in both. So this time if I give you the analytical symbolical definition, then it will be what? X such that X belongs to A. Earlier we wrote or, this time it will be and. And if you write symbol, we have the symbol also. We can write X such that X belongs to A, then this symbol X belongs to B. This is a symbol standing for AND. Now very immediately, without doing much, I'm going for representing this in the Venn diagram. So this time what will happen? Nothing is going to be happen, no separate thing. Again we have to draw two sets. This is one, set 1, and then we have to draw another set here. This is set B. But again, as I told you, you have to have something in common. Only this common part, remember it this time, only this common part is known as the intersection. Earlier we had the complete part, this were completely there as union. Here only this particular shading part will be intersection. And now if I write the elements, 2, 3, 1 will be here, 4 will be here. This is set A, this is set B. Universal set must be denoted, and this particular part, if I shade it, this is known as the intersection, right? So below you can write an index by making a shading. This is the intersection. So intersection means the elements which are present in both of the sets, right? So please note it down, and once you finish it, tell. Okay, very nice. Now moving on to the next board. I'll be discussing the properties together. Third operation. Third operation is difference of sets. 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 Now you see difference of sets. यहाँ पे मेरे पास कोई कीवर्ड नहीं है. I'll just explain you first, then you will understand what exactly it is. Again, I am saying that I am going to take the same example, then it will be more comprehensive and applicable. Now if I ask you to write A minus B, sometimes people write like this also. Both the symbols are valid. I write like this. So A difference B matlab set of all elements of A which are not in B. So you have to note down all the elements of A which are not found in B. So you go scanning one by one all these elements. 1 I have picked up. It is found here? No. So 1 will be a part of this. Then 2. Okay, it is found here. So you cannot take. 3. It is here. You cannot take. So this is here. 4 is not to be discussed because 4 is not here. 4 is not in A. So you have to look only from those elements which are in A and not found in B. So this is similarly, if in the same case I ask you to define B minus A, so this will be singleton set 4. So now to get the analytical definition, look at this set. If now I ask you randomly that you have to take one element from the difference set A minus B x, so you can say that x must be in A and not in B. This is the very sure command you can do. Because A minus B, you are keeping only those elements which are in A but not found in B. So from here we can have the definition, symbolic definition. A minus B means all those x which are found in A, and at the same time they should not be found in B. Similarly, B minus A, if I find all x which are to be found in B and at the same time they are not found in A. So these are the definitions which we have in the symbol. Now I'll be going for the Venn diagrammatic representations. So first of all, I'm going to write the universal set. As I told you, universal set is the first thing you have to always write, right? It is the universal set, U. It is the universal set. What happened? If I write U, okay, the color is green, so it's coming. I'm writing it U. This is the universal set. And then now I'm going to write two different sets. One set is here. I'll write it this side. Another set you have to consider. It is here. Okay. I'll consider it like this so that there will be common part. Always keep a provision. Always keep a provision. This set is A and this set is B. Right? So you have got this. Now here, what will happen? You try to see. This particular part over which my pointer is moving, this particular part, like the crescent, this one, this is A minus B because any element belonging to this will not be found in B. Here, this is B minus A, this particular part, B minus A. So this is what you have to remember. Now, if just for the sake you want to like punch the element here, so you can write it like this, that here there is a element 1, right? Here there is a element 2, here there is a element 3, and then the fourth element will be here, right? So this is the Venn diagram which will depict the example what I have shown. So from here, if I just draw an arrow, I can say that this is A minus B and this is B minus A. And very well already you understood that this part is the intersection. Please note it down. And once you finish with it, let me know. Okay, thank you so much. Now I'm going to comment on this figure only before I proceed further with any of the observations. What comment will you see? From here only, this will be treated as a property. So if you remember the Venn diagrams, everything becomes easier. A minus B. A minus B is nothing but A minus A intersection. So from A, if you remove this part, then you will be left out with A minus B. Similarly, B minus A can be written as B minus A intersection B. Now, why am I bringing this? There is a question, of course. Sorry. Actually, I need this relation when we'll be working on the number of elements. If tomorrow somebody asks you, find the number of elements in A minus B. So it is very, very clear to write it like this. Number of elements in A minus number of elements in the intersection. So to obtain this only, I wrote these relations. In the similar note, you can write number of elements in B minus A will be number of elements in B minus number of elements in A intersection B. Great. Once you finish, please tell me. I'll go for the next. Okay. Just wait for 1 minute. I'm sending a message to principal. Just 1 minute. Okay. So now I'll be going for the next set operation. That is very important again. That is a complement. We do not call it as an operation, but anyway, you consider CMO, what I'm writing, COMPLEMENT, complement of a set. Complement of a set. Complement of a set we have to do. Now here is a complement of a set. We need necessarily here the concept of universal set. I give an example. Universal set, say I consider the digit in the digital system, decimal system, 0 to 9, and I give you a set A, and I'm asking you that you write the complement of this set. So what does the complement mean? Complement means I have to form a set whose symbol is A to the power C, or you may write A dash. A dash. Right? Choice is yours. And this contains what? Remember very clearly, it should not contain these elements. Rather, avoiding these elements from this, you write the left out element here. So in practice, while writing this set, you should not spoil the original set. What here I am doing, that 1 is here, so I'll cut 1. So I'll write that 0 is here, so 0 is found here, but it is not, so 0 I'll write. 1 is found here, I'll not take 1. Then I'll see 2. 2 is not found here, so 2 I take. Right? Then 3 I say 3 is here, so cut it. Then 4 is not here. 5 is here, 5 I will not write. 6, then 7, then 8. Now, what did you understand? What did you understand? We have written all elements from you which are not in A. That is the complement of A. Now, if this is the case and you would like to represent a complement in the symbol, what you should write? All element X such that X will be found in the universal set. And at the same time, you should also guarantee that it should not be found in A. It should not be found in A. So this is the very important symbol. That is a very important symbol. Now immediately I'll be drawing the graph. That means the Venn diagram. Right? Venn diagram I am drawing. So here again, that is the idea. We have to draw sets. We'll draw sets. Here only one set I'll draw because I'm talking only about union. Right? So here I'll write this is the universal set. And then I'll write here this is the set. Okay, inside I'll write. This time inside we have to write. Inside we are writing this is the set A. This is the set A. Okay, and then you try to now see. If I ask you to write all these elements 1, 3, 5, 9, you will be putting somewhere here 1, 3, 5, 9. Fine. Then you were containing the set. You were containing what? 0, 1. I have written inside. Sorry, it is not 2. It is 3. 2 will be here. 4 will be here. 5, 6 will be here. 7, 8. So now from the Venn diagram, it is very, very clear. Leaving this part, whatever is found outside this A, this consisting of the union. This is consisting of the union. So if you would like to shade, you have to shade this part. This shading part completely. I'll not do the shading completely. And this is the A complement. And you should write always the index when you draw the Venn diagram. This is going to represent the union complement of A. Have you understood? Now I am asking from you the verbal feedback. Is there any questions, queries to complete or to ask? Because after that I'll be giving you the properties and then I'll bind up today. Any questions, Swarna?
No, sir.
Okay. So you have finished writing. I'll go to the next board.
Yes, sir.
Okay. So now I'll be writing the properties of all these operations together. All these operations together. Number 1, very first I write A union B equal to B union A, and then A intersection B is equal to B intersection A. This property is known as commutativity, or else you can write commutative property. Number 2, if someday you would like to take the union of three sets, you can take either first two sets union, and you can take first the second two sets union and then third. You can do this. The same is valid for intersection also. That means while taking the intersection of more than two sets, you can group them, and that grouping is allowed. It is called associative property. Next, try to understand. We have this time a different one. It is being misspelled or misunderstood by students with this property. Here the operations are same, but here you see operations are different. So here it will be distributive property. This A union B intersection A union C. If I get intersection here, union will be here, and then my sets will be A intersection B union A intersection C. Then I may be getting like this also, A intersection B, and then union is in the right side. So there's no problem. It is like the distribution only. So it is very much same. Only this time the distribution is done from the right. So this is what we have to write. So these are the four distributive properties. These are four. All are known as distributive property because you are distributing. But there is a term we can use for understanding. These two cases we have distributed from the left, right? And we have distributed here union on intersection. So first property can be extensively written as extensively. This is the extensive word. If you simply write distributive, it will be okay. I'm naming only the first property. I can write like this. It is the left distributive property because you are distributing it from the left. It is the left distributive property of union over intersection because you have distributed union over addition. So if you read like this, then this will be read as what? It is a left distributive property of intersection over union. Second property, if I discuss, it is the left distributive property of intersection over union. In the same way, this is right distributive property of union over intersection. That's the thing you have to write. So be very alert about this particular wordings. Number four. We may be getting like this union. A union A always will be A, and A intersection A is always A. This is called identity property. Sorry, not identity. Idempotent. Idempotent rule. Idempotent law or rule. Right. Next, I can get A union universal set. Then that will be always universal set, obviously because U is the biggest. Then similarly, if I take intersection with universal set, I get always this set. Union with phi, I'll be getting the original set. Intersection with phi will be always phi. So these are identity properties. These are identity properties. Identity properties. right? So these are the cases. Now next sum I'll write here. Actually next board is not being prepared by me. It will be having a white background, so I'm not doing that. Anyway, white background नहीं चलो. लिखा है. Have you finished with writing? Have you finished writing?
No, sir.
Please write. Please write. Okay. So I'll go for a whiteboard only. Next whiteboard. So let me see what property I have left. It is property number 5. So now property number 6. Property number 6. So I'll bring the complement here. Complement of complement is original set. This is called double complementation rule. This is very clear. You can understand this. Then once you get this, we'll be getting this also. A union B complement is equal to A complement intersection B complement. Then A intersection B complement is equal to A complement union B complement. These two rules are said to be De Morgan's law, and very powerful tool in our explanations. Very, very important. Then we'll be having some little properties. Phi complement is the universal set. Universal set complement is phi. Next, difference can be written. This can be written as A intersection B complement. I did not explain complement that time, so I did not derive it from the Venn diagram of complement. So you can now easily observe on Venn diagram. B minus A will be equal to B intersection A complement. Achha, you can use dash, you can use C also. Choice is yours. Right. So far, if we know about this property, it will be enough. And if by chance I have skipped any property, so you go through the book and then you identify those properties. Right? Please try to note down that property. Will be able to get this. That is not an issue. So please note it, and once you finish, raise your hand because I'll be signing off, and we'll see you in the next day. You will try to do the exercises, whatever are related to this particular chapter, this particular explanations. Please do definitely. And then if we'll be having any problems, questions, queries, will ask me. So bye bye.